Why study geography? In geography, we have several different perspectives that we take that are unique to our discipline. Some of them can also be used outside the discipline, but things that make us geography involve a spatial type of thinking, meaning we study things over space, like historians study things over time. Geographers study things over space. So we have a spatial perspective. We have a science perspective, scientifically thinking, trying to run tests and use statistics and computers and models to find answers to questions about life's mysteries. So spatial perspective, science perspective. We also have an environmental perspective, and we'll start thinking about that. Here is a iconic image taken from the surface of the moon looking back at Earth. They call it Earthrise because it looks like the Earth is rising over the horizon. It's not actually how it works on the moon because it's gravitationally locked with us. If you stood there all day, you would see the Earth looking like that all day. But anyway, this was life-changing for many human beings on the surface of planet Earth when they saw this. Keep in mind, back then they didn't have regular access to images from space and any idea really what Earth looked like in real life from outer space outside of artist depictions, and we know that those aren't always accurate. So when they saw this, people started to realize that the Earth is a finite entity. It has a finite amount of resources of water and clean air and so forth. And this really was an image that was used to help spark and drive the environmental movement going into the 1970s. Today we have amazing pictures of our planet. Here's this a shot from the International Space Station. You can see the aurora borealis. We see a shooting star from above looking down instead of down looking up. Basically, a shooting star is debris from space entering into our atmosphere and incinerating. So with this environmental perspective, we often think of Earth as a spaceship Earth, kind of like being on the International Space Station or on a spaceship. You only have a certain amount of food, of fresh water, of resources that you need to survive. And when we think about our planet as being finite, as having these systems that don't have infinite amount of resources, we realize we need to adopt more sustainable thinking and sustainable ways of lifestyles. When we look at the planet surface where we live, we can't go very deep into the earth and live subterranean. We can't live in the atmosphere. We can't. So it narrows us down to the surface, and we can't live out on the oceans very easily without bringing our materials with us. So that's 71% of our surface we can cross off. We have about a third of our land mass that we do have access to is desert and very inhabitable, as well as polar areas like the entire continent of Antarctica, not practical for humans to live on permanently, and that's about the size of the lower 48 states, the whole continent of Antarctica. We have various other places that have already been cultivated, wetlands, lakes, or rivers, and urbanized environments. So when we get down to it, there's only a small percentage of our surface left to create food to support our growing and swelling human population on the planet. Although we are the blue planet with 71% of our surface covered in water, it's ocean water, which in its current state is of no use to us. The salt content, the dissolved minerals, can't be processed by our bodies. We have to have fresh water that's migrated from the oceans through the atmosphere in the form of one form of precipitation or another, and fallen down to the earth and collected either in a stream or a lake or a groundwater resource before we can have access to it. We all share the same air that we breathe. Something that we get into in the next week or so is the atmosphere. We'll talk about environmental issues, pollution, ozone destruction, and greenhouse gases and global warming. If we think about the population of the planet, it's striking how it has really blossomed kind of in a scary way in recent decades and last century. Humans as Homo sapiens have been around from our best estimates of fossil records 100 to 200,000 years as Homo sapiens. So think about that, it's a big number, 100 to 200,000 years. And it wasn't until the year 1804 where humans reached a population globally of 1 billion people. So it took hundreds of thousands of years to get to 1 billion people. 123 years later, 1927, we reached 2 billion people. 33 years after that, 3 billion people. 14 years later, 1974, 4 billion. At this point, we all know people who were alive since possibly as early as 1927, definitely the 60s and 70s, right? So when they were children, the population on the Earth was less than half of what it is today in one human's lifetime. Think about that. By 1987, 13 years later, we reached 5 billion people. All right, 99, 6 billion. And today, we're over 7 billion people. By 2050, hopefully, all of us listening and tuning in will still be around then. The world is expected to grow to 9 billion people. So think about when you were born and then what it's going to be by the time you move on from this reality. The population has been growing exponentially. And when we have this type of condition, it really puts a lot of stress on that finite resource of land for growing food, arable land, and fresh water. It's kind of creepy too here if you look at the population clock. See, the U.S. population's over 300 million. We're the third most populated country in the world, behind India and China. You look at the world population clock. Now these are estimates. Every 10 years we take censuses and get a more accurate count of the humans on the planet. But each year we also have a very good idea of birth and death rates. And if you factor those together, you can see if your population is going to grow or shrink. And we know it's growing at such a rate that if you just do the math over a period of time, this is what you would need every second that goes by. You can just sit here and watch the world's population increase. Pretty wild. That's the U.S. Census Bureau's website. So here's a graph I made real quickly in Excel just to show this population in billions from 1804 up until 2050. So I think that, reflecting on population growth, the demands that we're going to have on the planet itself really is job security for geographers, and also kind of a driving factor in why you might find geography to be an interesting subject to study. So in geography, something that I'd like us to keep in mind going into that first exam is that we have kind of a schism between what we do, even though they branch together, they do work together well as well, but we have folks that are more physical minded, and those are people in the mathematical geography, climatology. This word geomorphology, that means the study of the Earth's surface, the shape of the Earth's surface. So that's things like plate tectonics and earthquakes and volcanoes and things that break down mountains like erosion forces, glaciation, coastal wave action, hammering away at a coast and making a beach over a long period of time. Biogeography overlap with biology, and soils geography. Really the three big ones are these in the middle. These are the ones you hear most often. And, we'll be focusing on elements of these throughout Physical 1 and into Physical 2. Also not on here would be an overlap with hydrology, studying the world's water, which we'll also do this semester. If you're more interested in the social studies, that's probably the majority of what geographers do falls more into the social sciences, not the sciences that we're covering this semester. But there is a social geography, a cultural geography, economic and political and historical geography. We do offer courses like that here in our department as well at JSU. But there are folks that like to focus on this middle part we call the environmental geography, and tying together the physical and the social, which is pretty unique. You don't really find a lot of that taking place outside our discipline. Not on this diagram is this whole world of mapping and what we call GIS. Chapter 2, which I'll have you read outside of class, dives into mapping and geographical information systems, computer mapping and modeling. And that's really students in geography that graduate from JSU or anywhere across the U.S., the vast majority of them are getting jobs in GIS technology or another field called remote sensing, using aerial photographs or satellite images for analysis interpretations that's useful to the military and to city planners and basically all kinds of different groups. We'll read more about that later. In summary, physical geographers study the climate, landforms, soils, vegetation, and hydrology. Human geographers, more interested in human systems of economics, social studies, cultural studies, political studies.